All right, well, thanks everybody. And thanks Calvin for giving me a chance to kind of show what our team's been working on. And so I'm gonna kind of give a little bit of a background. So I think I'm gonna speak a little bit to the why, to where we are and how we've gotten to where we are. And then I'm gonna give Calvin a chance at the end to give a little bit more detail on the how and how we've done what we've been able to accomplish. So a little bit about myself. My name is Nate Dotzlaf. So I'm executive director of our enterprise analytics group here at Indiana University Health. A little bit about me. I've got CS and philosophy background. Did my MBA at some point in time, and please don't hold it against me. I'm a PMP, Six Sigma black belt. So try not to let that get in the way too many times. I've been in technology for a greater part of 15 years in a lot of different roles, from infrastructure to software development. My journey here at IU Health began about 4 years ago, as I came over here to help us kind of move our data platform into the cloud, and to start to take on kind of more of a software development mindset around how we managed our data platform. Little background on Indiana University Health, for those of you that don't know. So we're the largest network of physicians in the state of Indiana, third largest employer in the state. We have a little over 35,000 employees. We are a nonprofit academic medical center aligned with the Indiana University School of Medicine. 19 hospitals and counting, as well as outpatient centers, home health care. We operate across many different verticals. So with IU Health Physicians Group, we have over 1,500 board certified physicians, I think 300 advanced medical providers in 200 locations across the state. But again, because of all of our verticals, we also operate with IU Health quality partners. We have IU Health plans. We have a variety of other business solutions. See the picture in the bottom right. We operate all of the Lifeline helicopters in the state of Indiana, as well as emergency dispatch. So a little bit about mine. So my group, Enterprise Analytics, sits in our overall IS department, a little over 1,000 IS team members. My particular group has a little over 80, divided into 3 core areas with a mission around self-service. So our data management team sits in the center. This is our data engineering group, our data operations, as well as our ML engineering group, responsible for what I kind of call the core of our onion. Our analytics delivery team sits on the outside, so kind of think of them as our consulting function. We have a pretty strong focus on self-service analytics, so we support a variety of teams across the organization with varying degrees of either size. So some teams are 1 or 2 members, some are 15 to 20 member teams that we support, and varying levels of proficiency. So some are junior analysts that get hired in and have no team members or support, and we work to support them, as well as executives that may not have their own analytics team, and that's where we bring stuff kind of in-house. Our third group is around research analytics. So the research analytics group works with our School of Medicine around cohort identification for any medical studies and those types of things. So a little bit about kind of evolving world of data at health, and this is a pretty exciting space to be in. I think it's a really exciting space, primarily because a lot of the challenges that were faced back in the day, as with many things, are kind of exploding with the opportunities that the cloud provides. So this kind of graphic is we kind of go from that, like in the early 2000s, as data kind of came on and the concept of internal BI teams, single boxes, SMP, we'll call SMP boxes, and then the evolution to MPP platforms, so massive parallel processing. We had one called Analytics Platform System, but Teradata, there's a number of other players in that space. And then the move into cloud, which we completed in 2020, where we start to pick up a lot more capabilities. And then kind of where we see ourselves going, and this has become a really big topic for us, is genomics, data, precision genomics specifically. And so we're starting to see an explosion of the amount of data that we're bringing in and the number of sources of data from which we're being asked to pull data. overall, from a strategy perspective, so our team here at an IS is, and in IU Health is driven by our commitment to what we call our core values and our promise to the patients. We deliver that through what we call a contemporary digital experience, and that's driven by three key areas: high reliability, advanced analytics, and digital transformation. And my group sits in, obviously, in that advanced analytics space. And if we kind of step back from that and look at our mission, a lot of words there. It kind of comes down to advanced analytics needs around AI, ML, NLP, precision genomics, and the number of team members that we're supporting there. All of those things get a lot of attention. It's what people are wanting. It's in the news. It's on the headlines, the AI, ML, NLP. But our teams kind of come back from perspective, like at the end of the day, the foundation for all of those advanced needs comes down to the data. So I kind of go back to this quote from, which I think is hilarious because it's from back before any of what we're doing right now was even anticipated, which is data, data, data. I can't make bricks without clay. And we find that to be very true in the analytics space, and what we see from all the ML teams and all the people that want to be data scientists is at the end of the day, the amount of data that we're sending still is a primary concern for those teams and is a big limiter in what we see from a success perspective in those projects. 80% of the project still comes down to data engineering and data movement. And the 20% is the extra sauce at the end. So kind of in that overall goal, so we see the pipelines, what we call pipelines, as our primary, the foundational technology to enable all of our downstream analytics teams. And while it has a computing specific definition, I kind of like the one coming from the finance background, which is progress towards a long-term goal that involves a series of discrete stages. We defined those stages into kind of 4 or 6 different focus areas. So configuration, orchestration, ingestion, transformation, logging, and then what we call our access layer, which is where the end users are able to access the data that we're pulling through the pipeline. So where did we start? Back in the day, we had data movement, and unfortunately, we see this quite a bit in other organizations, which is on-premise, GUI-based black boxes that everybody has to enter in. They're not extensible. They're not scalable. We're dependent on vendors. And this is the state we were in prior to 2000, prior to our move to the cloud. So we didn't feel that was isn't where we needed to be in order to meet kind of the new upcoming needs. I feel like we got pretty lucky because our big on-prem box was end of lifing right at around the time that I think the cloud hit that capability level where it made a lot of sense to move in. And so we were kind of right time, the right place to do that. When we envisioned our first pipeline and began that journey, kind of focused on a set of core values that doesn't differ a whole lot from where we want to be today. The one big difference is because of the amount of move and because we had a lot of existing processes already, we focused in and maybe didn't push as far as we maybe wanted to in order to minimize risk to existing processes. So while we were able to get next-gen capabilities in the cloud around data capacity, availability, and the scalability, and minimizing the tool sets and getting into a space where we were out of the black box, had some separation of concerns, we still didn't quite get to where we wanted to be from the overall perspective, mainly just because we needed to focus in, and all efforts were driven by that minimizing risk to the existing processes. So a little bit of graphical overview of kind of where we ended up. So going from that on-prem system to what we call our current state pipeline V1, which we completed February 2020, which, as everybody knows from a date perspective, is just in time for COVID. So The pipeline V2 that we're going to talk about today was planning to start that year, and it has now taken us into 2022 to start to come to the completion of that project. That said, it was, again, perfect timing. If we had not completed this when we did, we would have been very unable to meet the scale and demand and a lot of the new technologies that we were able to employ relative to our overall organization's response for the COVID. COVID emergency dashboards, our ability to ingest data from a bunch of different sources very quickly. We were able to turn where we had been on a 24-hour batch cycle. For specific loads, we were able to turn those into hourly feeds, which would not have been a capability that we would ever have had in our prior system. In addition to that, over the 2 years, we've totally blown out any projections for the amount of data that we're bringing in. We've gone from about 1,000 tables every 24 hours to over 5,000 tables today. We're expecting to see that grow based on our backlog, which just continues to grow. We're approaching, for some scale and reference, we're approaching 1.5 petabytes of overall data in the system. And we expect that to probably double over the next couple of years as we start to really focus in on precision genomics and doing full genome sequencing for a larger percentage of our population and eventually going to be for every one of our patients that's coming through the door.
And this is also when you first started using some Python in the pipeline, correct? I see like Databricks is here.
Absolutely, yes. So kind of the key components here on the, we got to some of our goals around, we wanted a single configuration to drive. So we have JSON configurations for each table that we put through the pipeline. We were able to bring in and use Databricks. So we hit some of the levels, but I think in my next slide, I'm going to go through some of the things that maybe we didn't hit on very specifically, because this isn't exactly where we wanted to be. And there's some downsides that the team found out after the fact and kind of have, despite our growth, that we've had to figure it out, but learned a lot of lessons the hard way to a certain extent. And I'm going to go through those here in just a second. But as we started to envision our pipeline V2, we hit some of our goals, but we're really starting to look into the demand for to change from a traditional, it's the EDW or it's the data warehouse. It's 24 hours and be satisfied with that. Our analysts and our downstream users, we can say that all we want, but it's the paradigm is shifting to that is no longer where we need to be. We need to be able to support near real-time data sources. We're going to have to be able to scale for that additional capacity with the remainder of the data. We need more processing power in order to get to what we call SCD type 2 capabilities for slowly changing dimensions. And as a nonprofit, we're very tight on the amount of budget that we give to maximize the dollars that go back to the organization to provide patient care. So we need to, we can't always buy the big market tools that take a lot of the underlying infrastructure and on a large team. We need to be very lightweight. We need to minimize the number of tool sets. We need to decrease configuration and be able to run pretty lean. Reducing infrastructure costs, big part of that. And then for us, and kind of coming back to that vendor lock-in that we've found ourselves in, is a desire for our team to embrace open source software. Now, what we've done there is we've been very specific where we search out for enterprise partners that are able to help us support that with a 24/7 support. But that open source kind of reduces us from that, reduces the vendor lock-in and costs that we see out of the pipeline. And it also improves our portability between the clouds as we kind of extend out and see more opportunities to utilize solutions that may be not in just one cloud. So I'm going to do a quick run through for these, but just kind of going through some of the specific points and kind of where we ended up. So this is one of the big pieces where I think we missed in our original V1 is we had this idea of a single configuration, one stop place to work on a table, and deploying that out what we ended up with was those single configuration files, but then an additional mix of configurations buried in SQL database tables, still some amount of manual configuration with tools that really weren't capable of programmatic interaction. The API surface was not where it needed to be in order for us to drive true CI/CD. These are the fun slides that do the double one. So getting to our future state, so Terraform, Azure DevOps, we want to get to one file per table, and we want to drive all deployment of artifacts, including infrastructure, notebooks, DAGs, and Airflow by pull request for a single configuration file change. Orchestration. So our current state tool is a tool called JAMS. It is a Swiss Army knife. It does everything. Unfortunately, that everything creates quite a few problems for us. So what our goal here was to look for various data-specific tools, and then kind of coming back to, we want to minimize the number of languages. So again, Python being that more ubiquitous tool that we're seeing in the space right now, and lets our teams focus in on only having to be excellent on the one language. Ingestion. This is probably one of the bigger pain points that we had. We chose Informatica Cloud at the time. Azure Data Factory version 2 had just released, and version 1 was not fantastic. So from an overall risk perspective, we went with Informatica Cloud. Now, anybody that's dealt with Informatica, that kind of gets us into every time you want to do something different, you purchase a new connector, which is just not feasible for us. And even then, being stuck behind development pipelines for new tools of 6 months to 1 year, and we need the flexibility. In the meantime, we've turned to PowerShell and a number of other ad hoc solutions. But from an ingestion standpoint, we're consolidating in on one tool that lets us do everything that we want to do right now. I do want to kind of point out, we'll see a little bit later, is Azure Data Factory with separation of concerns is our tool for data movement right now. But it is a place where we kind of built out and the separation so that that can be kind of rotated in and out as other tools come up. It's not part of what we call our core. Transformation, and this is to Calvin's earlier comments, like we did Databricks. We are using Databricks Delta tables. The downside was we had at the time a team of developers from our prior vendor that came from a SQL development pipeline. So what we ended up with was one monolithic notebook that did everything. It ingested the data, it transformed the data, it stored the data in Delta tables, and it pushed the data downstream. As anybody in this group might know, that does not always work well when things go wrong. It's a hard time. It's one of the many places where the team has had to kind of adapt, and every time a problem comes up, is they're looking in a bunch of different places to find the overall problem. So future state with Databricks, and we work with both Databricks and 6 Feet Up on this. This was a project last year around finally kind of separating out the concerns. And so our future state will be a true raw bronze, silver table structure where each part of the ingestion pipeline is wholly independent of the other pieces. So when we have problems in that pipeline, we know exactly where they've occurred. So logging. With cloud, we got lots of logging. We can turn on logging with all our tools. It's excellent. But again, the whole where do you go when something goes wrong? Our future state is around centralizing that logging so that the team has single panes of glass, or at most 2 panes of glass. We feel the Airflow offers a pretty good for what we call kind of our data acquisitions development team, and then core like Azure Log Analytics for our more advanced, our senior developers, our architects to do more deeper dives into troubleshooting. And then access layer, and this is, I'm kind of popping around, apologies. So access layer, this is one of the primary drivers. So we've been on what we call the EDW Azure Synapse Pool model, formerly known as the data warehouse. It is very similar to the MPV platform we were in on-prem. As part of that rush and minimizing our risk, that is still our primary storage vehicle. But when we're driving advanced analytics, that is great for servicing our downstream business customers that are used to SQL and used to standard paradigms. For data science, it is very not sufficient. What it's led to is a pattern of every time we have a project, we now need to do additional ETL work to get data back out and into a vehicle that is useful for all the different downstream tools that are starting to pop up around ML and AI. So our future state here and where we really want to get to is our data lake layer, our Delta tables are our primary storage vehicle, because that kind of enables us to take advantage of all the new multiple emerging tool sets. We'll continue to have our SQL data warehouse for those business users, but now we're going to open up additional capability for all the data scientists without having to jump through a lot of hoops. So just real quick here at the end, and I think Calvin will dive into this a little bit deeper than I will, but this is where we kind of ended up as a pipeline V2 future state. And one thing that came out of this kind of arrangement is we'd always envisioned our pipeline to be the entire breadth, so kind of from source all the way down to the serving. One concept that we've adopted over time is what we call the pipeline core, and that core, as you'll see, is developed primarily through open source technologies. Where that benefits us is we have a lot of different vendors. We are a very large organization, so there's no one single tool for us. And we're seeing this additional need where we're adopting Google Health Engine. We have stuff in AWS. We have certain vendors in AWS, and our ability to, we have a high degree of need in order to operate across all of those platforms. And the design that we've gone with here around the pipeline V2 core enables us to kind of lift and shift. We can either replicate this across multiple clouds, if we need to at some point in time shift our primary platform, then we're able to lift these technologies and kind of rotate in and out. The two pieces here, that Data Factory and Log Analytics, are kind of outside of that, but because we separated those out, because the Data Factory from an ingestion standpoint only lands in raw, we're able to, that's a tool we can rotate in and out because it's separated conceptually from what we're doing from an Airflow and Databricks perspective and storage perspective. So, and by that core, now we have what we call as our serving core, and we're able to serve not only that core from the primary serving layer, but starting to pick up all these additional advanced analytics needs around ML, Google Cloud. Big one right now is Terra, so our precision genomic partners downstream. So kind of from a timeline perspective, we just finished with our initial production pipeline. So we got our first pipeline running, or I would say Calvin and team got the first pipeline running.
Yeah, it's exciting.
Week, just under the wire. And what we're doing now is kicking off continued development, but that initial production pipeline was based on one source. So we are going to be beginning to migrate that data. And as we start to wrap up and continue development, we'll continue the migration of sources. And right now we're on target to complete our migrations by Q3, Q4. So hopefully that's a little bit of the why. So that's kind of where we are. And then I'm going to turn it over to Calvin to maybe go through maybe the more fun bits of how we did it and how they did it and where we stand right now.
Absolutely. Let me share my screen. So approaching this problem was really a lot of fun because IU Health Group and Nate with his leadership was really behind open source Python. Leveraging these best of breed tools gave us a chance to really dive in and find out what the state of the art is for many of these things. I guess unbeknownst to us, some of these things haven't been done by other organizations and other groups. And so we were able to actually, I guess, trailblaze a little bit with this specific project. So it really one of the key bits here that has been driving a lot of the behind the scenes is this use of Terraform for all the infrastructure. Being able to deploy an ad hoc environment quickly to be able to test changes, experiment, understand how something's going to affect the whole pipeline, and be able to do it in your own sandbox is very powerful when you know that that sandbox matches what you're getting ready to deploy to in your dev environment or your staging environment or your QA environment. You get a lot more confidence as a developer building these configuration files and onboarding new data sets that this is going to be a lot more successful when we go to launch, and also easier to debug because I can now pull back and use my own environments to actually debug in real time. For most things, almost everything I'll show you in the big picture at the end here is deployed with Terraform, except for the Azure DevOps pieces. Still a little by hand, but everything else from the data factory that Nate mentioned, all the way through to even dedicated SQL pools, we're deploying just by a single CI pipeline running our Terraform and blowing all this infrastructure into existence, except for the DevOps pipelines, unfortunately. So that comes in two kind of flavors for us, which is the bootstrapped infrastructure. These are all kind of the table stakes things needed to even run this data ingestion and data pipeline core that Nate referred to. So everything from setting up a blank, perfectly empty data factory, the Databricks workspace, the Astronomer, deploying Astronomer, Airflow into Astronomer, having all the storage accounts set up correctly configured and ready to accept data at these various layers, and everything in between. And now that doesn't count, this has nothing to do with the configuration files yet at this point, but this is all the groundwork and the foundation that's laid and needed for us to be able to actually deploy the configuration of these tables into the environment. The last bit is really that configuration-driven infrastructure. So we looked at a couple different tools. We really wanted to make sure we stayed with Python as our tooling for deploying this specific infrastructure. And what was interesting is that if you're familiar with Amazon, they've got the CDK, the Cloud Development Toolkit. There is a version of that for Terraform, which would have allowed us to use, kind of a language agnostic. You can use Python, you can use Node or TypeScript to develop your infrastructure pieces. Unfortunately, it's not quite there for using it in various other environments. So when we wanted to actually go and use this tool, there were just missing pieces, missing calls. I mean, that's kind of the upside and downside of open source. If we had time, we could have actually, participated in the open source community and made pull requests to get those changes in. Unfortunately, given the time constraints on the project and the needs, we didn't have time to finish off and help them with the CDK Terraform piece of that. But it is an interesting project, and I would recommend folks to take a look at it. But when it comes to doing things like data pipelines, as opposed to maybe deploying a web application, the web application probably would have been a lot more successful. The data pipeline pieces maybe are lagging behind a little bit. So we turned to Jinja 2. We are actually taking the JSON configuration files that were mentioned and processing those as Jinja 2 templates. So we have Terraform that's actually a Jinja 2 template, leveraging modules that are actually terraformed in Jinja 2 as well, to deploy this infrastructure and make it easy to build these generated Terraform files on the fly. So as an example, I'll show a real quick example here. If you have a specific table, in this case, it's going to be the admin address table, you can put together a easy to edit, easy to maintain and check into source control description of that table as just simple JSON, which is nice because you can diff it. It's easy for developers or analysts to onboard new data sources, because really all they need to know how to do is generate some configuration. And in this case, you could actually point it at a data source and get an initial skeleton configuration, manually go through and massage that as needed, and then take that JSON configuration file and now apply those variables into Terraform. So we generate multiple Terraform files, one Terraform file per table in that configuration file, and fill in these blanks here. So you can kind of see the source part under source table, and we're actually using a Terraform module. So all these variables in this specific module are passed into another Terraform module. so we can keep the commonalities all tucked away nicely into a specific Terraform module, and then just pass in the variables from this specific Terraform module. So the end result of that structure is that these pieces here are all maintained in source control, and anything with the prefix of generated underscore is actually generated as part of the developer's lifecycle of producing this configuration file on their local desktop machine. They run a make command to generate Terraform. It now generates this Terraform that they can now inspect, they can validate, they can run it through linters, they can use all their tooling locally on their IDE, whether it be PyCharm or VS Code, very easy to onboard these new sources. So you can see the SourceSmart pipeline module that we're leveraging from that address Terraform is just underneath that modules directory in the SourceSmart pipeline. So these include the basic building blocks right here for how to produce a pipeline inside of Data Factory for importing or ingesting that specific data source. And the output from this is what this looks like, is going to be the ability for us to now test that generated code. So as a source developer, I can build my JSON configuration file, I can test it, validate it, make sure that there's no obvious errors in this process, and hopefully increase that velocity for moving from a source database data source of some kind, whether it be an Oracle database or an API or flat files. That's what's nice thing about the Data Factory, is it gives us that flexibility for configuring an infinite number of sources that are supported by that one tool. And then we now build a Python wheel from this configuration that we publish into, in our case, we're using Azure Artifact to publish the wheel. And we also publish to a second spot, which is going to be our Gen 2 storage that our Databricks workspaces will pick up and use. So you can actually pip install that same configuration that you're using for the Terraform also into your Databricks workspaces, so that the notebooks now are aware of the incoming new tables. And so when they go to process their tasks, they've got the configuration really accessible for them. Once that all goes through this pipeline, we Terraform plan, and if all goes well, we apply. There's kind of a visual here for what that actually looks like, is this from the left to the right, how we move from a JSON configuration file pushed into the repository and then managed through a CI/CD pipeline. This pipeline here specifically handles all that validation, all the building, all the Terraform planning. And now you can actually have a code review, manual release gate in the process, so that if you've got maybe more junior staff can actually handle a lot of these tasks with confidence, knowing that there's someone maybe more senior who's going to review those kinds of changes. And then doing the Terraform apply. Through that application process, we actually take metadata from the Terraform runs, and we publish that metadata into Azure App Configuration that gives the ability for the Airflow and the Databricks notebooks can now query for specific kinds of IDs or information about that pipeline to know where to go find data when it runs through those notebooks. It allows us to keep the notebooks a lot simpler, so they know they got a store to look up their data. You'll see this trigger container build. Now I'll talk about that next, but from here, once you've got the wheel over in your artifact repository, Airflow now needs to be aware of that new configuration. And so we actually do an Airflow deploy with a CI pipeline as well. Using Docker and a multi-stage build, we can leverage the Azure private repository, pull in that specific egg, and you'll see it right here. It's called EDW ETL configuration. We can now basically use the Astronomer in this case provides some really nice base containers for you to build into your CI pipeline, or even use as a local developer. Developers can actually Docker compose and build these containers locally, running the local code that they are running or working on for the new imports, and make sure everything's going to work out before they even get this pushed into the cloud environment itself. So greatly helping speed up that iteration process in the development pipeline. You'll notice, and I mentioned this in my previous talk from yesterday, we're doing a multi-stage build here. One thing you're going to want to watch out for if you are new to doing containers is when you build a container, you want to be careful not to embed secrets in that container. So in this case, our container is very plain. This is actually almost a full example of how we build our Airflow containers. Everything else that's provided to that container that it needs, for example, connection strings for app configuration or how to talk to other infrastructure inside the cloud, is all provided via environment variables from the Astronomer platform. The one secret that we do have in here that you want to watch out for is, for example, this pip extra URL will include basically an authorized, kind of pre-authorized link to the private egg repository or wheel repository inside an artifact. So we do a multi-stage build so that that artifact doesn't go into the final image that's actually pushed into the astronomer container repository. So just a little bit of extra attention to security, things that might trip up people who are new to doing deployments like this with containers. And so this all ends up in, this is kind of that big picture. This really relates back to that final state that Nate showed during his portion, is that we've got our repos, all this managed in Azure DevOps, where all the code goes into single spots, where we run all our CI pipelines. This whole process probably now uses almost a dozen CI pipelines between the Bootstrap infrastructure, setting up, like for example, we use Atlantis to manage pull requests. That's a nice tool that can do Terraform plans and applies, and you can interact with those via the pipelines and pull requests so that you can manage that process of getting code moved from developer workstations to the dev environment, to the staging environment, and onto the various production environments. The build, then I mentioned, triggered those Airflow deploys. We actually push into Astronomer's image repository, and from there, Astronomer manages pushing out the various environments for that Airflow container. It manages the release process. So as new versions of the config files come out, as new sources are brought online, the Astronomer releases will drain existing tasks, deploy new pods and new containers into that environment with the latest versions of the code so that new tasks kick off. We'll start using the new configuration and bringing in those new sources as the pipeline runs. And then that Airflow is orchestrating the data factory and the Databricks portion of this to basically build that or bring that data across that pipeline from Oracle sources in this case to the SQL data warehouse, leveraging all the nice Azure cloud nativeness pieces of this. And kind of Nate mentioned, the flexibility and the ability to move between clouds is actually nice to have here, in that Terraform itself is cross-cloud. We'd have to rebuild those state files to support some other specific cloud or any specific services we wanted, but we're not tied in directly to just ARM templates and only Azure. There's an understanding here and a set of open source tools that are actually powering this whole bit. And that leads us to, I'll kind of show the finished state here. If you're familiar with Airflow, we've got now all the DAGs inside of Airflow are generated from that configuration file. This is all dynamic. We don't hard code these DAGs. These are fully generated using Python. And when runs go through, we now have the ability to inspect each of the stages along the way. So from the raw to the bronze to the silver to the SQL DW. And you can see here the last run was being fully successful. But you can now inspect and look when there's errors. It's easy for an analyst to now click through, go into the log, see what happened, see where errors are, and be able to diagnose and debug any kind of issues. So I'm really happy with how this has all turned out and the way this deployment has gone. That Terraform also builds out, like I mentioned, all these resources. The Bootstrap was giving us the base data factory, but that Terraform inside the configuration repository is what actually builds out all these pieces. None of this stuff is touched by hand. And if it were to be touched by hand, the Terraform can actually put it back the correct way it should be just by running that CI pipeline again. So that's kind of where I want to end it. If people have questions about the infrastructure and those kinds of pieces, I'm sure we're more than happy to take those kinds of questions. I'm going to stop my share now. But again, it's been a really exciting project for us, and a meaningful project too, because we're helping a local organization hopefully do better with the data they have at hand, improve the care and the lives of other people. And so that's what keeps us very excited about awesome clients and partners like Nate and his group over at IU Health.